Hi everybody, this is our video on correlation and regression. And in this video, we're going to start talking about correlation, and then we're going to move to scatter plots, and in class we'll finish up all the regression talk. So before you do anything else, I want you to think, have you ever heard people talk about correlation in everyday life? And have you ever talked about two different things that are correlated to one another? Now, technically, correlation is a relationship between two or more things. One common correlation chart that all of you have seen, well, I don't know if you've seen this before, but your parents definitely have seen this. It is a growth chart for babies. So whenever you were born, you were probably somewhere around 20 inches long. And there is a relationship between the age and months of a newborn and then the length in inches of the baby. And obviously, as babies grow, which they grow very quickly, which is why it's so steep here, they get longer. So right here, this is a length for age percentiles, and depending on how big you were as a baby, you were either in the 50th percentile, which meant you were right in the middle, you were in the 90th percentile, which meant you were longer than 90% of babies, or in the 10th percentile, anywhere in there. But again, if the X variable is getting larger, in this case age, and at the same time Y is getting larger, in this case the length, that is a positive correlation. So whenever your parents took you to the doctor, they would compare your length to this chart. Here is another more simple diagram of the same thing. The doctor would also take your weight every month, and they would plot you on a similar correlation chart to see what percentile you were in. So these are examples of positive correlation that you would see in everyday life. There's three main types of correlation, and they are positive, negative, and none. So take a moment and write down the following here. Correlation, again, is a relationship between two or more things. We're going to mainly consider them variables. And they can measure how interdependent two things are. Do they completely depend on one another? Are they completely unrelated to one another? It'll tell you those things. Scatter plot, you've seen them before. It's just a set of data pairs X, Y. And the three trends are as following: positive, negative, and none. Now, a positive correlation, you can just draw yourself a quick sketch here. If Y tends to increase as X increases, so as X gets to the right, Y goes up, that's a positive correlation scatter plot. A negative correlation would be the exact opposite behavior. So as your X's increase, your Y's decrease. So that would look something like this. As your X's move to the right, your Y's get smaller and smaller. Now, if there's no obvious pattern between X and Y, so as X is increasing, you have no idea what Y is going to do, that would be none. Your points are just all over the place. There's no relationship between your two variables. So if you haven't copied this stuff down yet, or you haven't paused yet, pause the video now and get these brief notes done, and then I'm going to move up. All right. So here are just two other examples so you can see positive and negative correlation again. Number of missed classes versus exam score. There is a negative correlation. As your X's increase, as you miss more and more classes, the Y's decrease. On average, your exam scores go down. A negative trend here. This one, you do not need to write these graphs down. Just look. Right here, precipitation versus cucumber yield. So this would be a positive correlation right here. This one was a negative. So as the precipitation, or X, increases, the cucumber yield, or Y, increases with it. You can see the trend. They are related to one another pretty strongly. To see how strongly two things are correlated, there is something called a correlation coefficient. The correlation coefficient will tell you if two variables are really, really strongly related or if they're totally unrelated to one another. We always use the letter R for correlation coefficient, and your graphing calculator can get you a really good approximation for R. The thing with R is it's always between -1 and 1. It can be any number between there, any decimal that you can think of. And again, it measures how well a line of best fit will go through a set of data pairs. And we'll talk about that throughout the video. So what I want you to do is draw this number line here. The smallest that R can be is -1. The largest that R can be is 1. R being 0 would be right in the middle. And if R is 0, this is the same as no correlation. Your two variables are completely unrelated. As X increases, you have no idea what Y is going to do. If R is on the positive, or if R is positive, this is all positive correlation. I'm abbreviating correlation. If R is negative, these are all negative correlation. And again, R being 0 is right in the middle, no correlation. The further you move to the right or the left, the closer your points will be to an exact line. So I definitely want you to write down this entire visual right here, but probably something that will help you see this is the following right here. You don't need to write all this down. This is just to help you see it. So if R is very close to 1, then you would be able to draw a line through your points, and it would hit pretty much every point. If you're really close to -1, you would be able to draw a line with a negative slope. Through your points, it would hit pretty much every point. R being 0, you have no idea. You can't draw a line. If R is close to positive or -1, the closer it is, the closer your points are to a line. So these are still pretty close. This is still considered a high correlation. In real life, you would never have exactly 1 or -1. It just doesn't happen. You would probably have something more like these two. A low positive correlation, about a half. This is pretty typical of a half. You can see a positive trend, but the points aren't exactly that close to it. -0.5 is similar, just a negative sloped line can go through it. And again, you can have 0.25, 0.3. The closer you are to 0, the more spread apart the points are from a line. So take a moment and definitely write this visual down. If it's going to help you at 0.5, you can draw an example of something going up but not that close. At -0.5, you can draw one with a negative trend but not that close. These 5 do a pretty good job of explaining it. I just really like this visual here. All right, now you do not need to write the following graphs down. Just look, pause, and try to answer on your own. So for these, I have 4 total of these. I'm going to show them to you 2 at a time. I want you to look at them, and I want you to estimate what R would be as a decimal. And then I want you to state the kind of correlation that it is. So for each graph, pause the video now, and I want you to think, what would you estimate R to be? And are you saying positive, negative, or none? In just a second, unpause. All right, so you should have estimated quickly in your head. This one is definitely a negative correlation. There's a downward trend. And in terms of estimating R, definitely no more than -0.5, maybe -0.5. You could even argue -0.4, make it go even closer to 0. Here, this is definitely a positive correlation, and this one's a pretty good fit. If you guessed a 0.8 or 0.9, that's going to be pretty close to what it actually is. Next two, pause the video, do the same for these two, positive, negative, or neither correlation, and what do you estimate R is? So pause now and then come back. All right, this one right here, pretty much no correlation. As X increases, Y is increasing and decreasing. Like this guy's going up, but this guy's going down. You're all over the place. That means R is 0 or very close to 0. This one right here is a little bit more spread out, but it is still a positive upward trend. And I would guess R to be like 0.5 to 0.7, anywhere between those two. Calculators will give you an exact approximation for R. All we can do is estimate it. Okay, now right here, take these notes down, please. So if you want to pause first and then listen, or listen and then pause, it's up to you. If R is close to -1 or 1, so one of these two situations, then what you can do is draw a really good line of best fit through the data. Now, you should really do a line of best fit only if you're relatively close to -1 or 1. You should not do a line of best fit if your R is like 0.2, because it's not going to describe the trend well at all. It's unpredictable. So here's your line of best fit. And your line of best fit should lie as close as possible to all the data points. You can approximate it by hand, or you can use a graphing calculator, which is obviously a much better approximation. To write these notes down here, we're going to do one together in the video, and then you'll finish one in class. We'll do 2 by hand and then 1 in the calculator. So to do it by hand, first you obviously have to plot the scatter plot on graph paper. Use up as much of the graph paper as possible. With a ruler, no wiggly lines here. Draw the line that appears to follow the trend most closely. Your goal is to get as many points above the line as below the line. Your line doesn't need to hit tons of the points as long as it follows the trend and generally goes through the middle of the points as best as you can. That's a good line of best fit. Then you choose 2 points on the line, because to write the equation of a line, you need 2 points. Now, these 2 points do not need to be those original data points that you plotted in step 1. They can be points on the line that were not data points. It's totally fine. And get their coordinates, x, y. Then you're going to write the equation of the line of best fit that passes through the points. You find the slope first, and then you can do mx plus b or y minus y1, either of those two. So what we're going to do in the video is practice one by hand together. So get your graph paper. Period 3, I had you grab graph paper. Period 7, I don't think I had you grab one. So if you have graph paper, use it. If you need to print some, there's a link to graph paper on my website under the resources tab. Try to get your hands on graph paper somehow. Otherwise, it won't be super accurate. And we're going to use MySpace data. Remember MySpace, guys? So MySpace was big whenever I was in like middle school, and it's kind of gone downward since then. And this is going to show the number of unique MySpace visitors in the USA. So we have users versus time. This is a date, and then to plot it easier, we're going to let T be the number of years since January 2013. Now, MySpace reached its peak in 2008, and since then it's been going downwards, sadly. So write down this table, and we're going to plot it first. So pause, write down the table in the corner of your graph paper, probably the upper right-hand corner is best. And then I'm going to move down here and plot my data. You go ahead and get a good scale here. Now on the x-axis, getting a scale is something that sometimes people struggle with. I only need to go up to 2.5, so I'm only going to go to 3 on my x-axis. My y-axis, I'm going to go from 0 to like 60, a little bit more than this. So I'm going to get a scale, and I'm going to plot my points. So here's how I'm setting up my scale. I spread it way out. The bigger or the more of the graph paper you use, the better your graph will look. So get your scale set up. You can use mine if you need to. And then pause and then plot your points. So I'm going to pause now and plot my own points, and then we'll check in again. So your data should resemble this. Our next step is to draw the line of best fit that follows this trend here. Okay, it's going to look something like that. Now, we're going to get a ruler, so grab a straight edge, your phone, a piece of paper, a folder, whatever, and I want you to set up your straight edge or ruler so that you have about as many lines above it as below it, and with a ruler, I'm going to clean this up in a second, something where you have as many above as below. So I'm going to pause and clean mine up, and then we'll compare, draw it all the way from the left all the way to the right. Here's my line of best fit. This is a pretty decent one. I have 3 points clearly below it, 3 points clearly above it. Mine happens to go exactly through one of the points right here. Now, the reason you should always go beyond your largest X and largest Y on your scale is because, look, if you had stopped at 50 and your paper ended, you would never be able to see what the y-intercept would be up here. So I probably should have made my scale go up to 60 and up to like 4, because now I'll never know what my x-intercept was. But it's not the end of the world. For the future, we know. So I need 2 points here. I am going to use one of the data points, which was 2.25, 25.7. And then I need another point on the line. Now, none of these other points are on it, so I'm going to go searching for a perfect grid intersection. That one's pretty good. So look on your paper. Look for any perfect grid intersections. Like I'm going to pause and show you which one I'm going to use. So this is my point. It's important to know what your scale is. Mine went by 0.05 on the X and 2 on the Y. So I went down and left, got the X and Y coordinates. So now that you have 2 points, you can plug into the slope formula and get the equation. So use your 2 points. You might not have my points. So for your 2 points, get the slope, find the y-intercept, and get the equation. Yours will be different than mine because you have different points. And then real quick on another piece of graph paper, just plot this as a scatter plot.